Hello, and welcome back to another episode on math and science problems. Today, we will be talking about the equation of a circle. But before we get started, please make sure to like, share, and subscribe to this channel for more interesting and fun STEM problems and concepts explained and proven. Now, let's begin. Now, when it comes to the equation of a circle, typically we are able to see it as a circle on an x and y plane. Now, you may be wondering, how is the equation of a circle correlated to how it looks? Well, all circles are written in the form of this. So this is the equation of a circle. Now, x and y, respectively, are essentially the x and y components when it comes to the actual graph. So if this part shows x minus 5, then that means we're going to be shifting 5 units to the right. Same case for y. If y is y minus 3, we're going to be shifting 3 units up. So x and y essentially tell us where the circle is shifting. Now, when it comes to h and k resemble what specifically and how specifically we are moving. So for k and for h. So as you may have learned in algebra, first touching upon graphs, if h is positive, you will be moving to the left. If h is negative, you go to the right. And this is because when you set it as the zero property, you get x minus h is equal to 0, and you get x is equal to h, leading it to go positively um, to the right. And that's essentially how it works. So when it comes to that part of the equation, that is essentially how it works. Now, when we look to the radius, or how big the circle is, this is where things get interesting. So r, being the radius, is how long it is from the center point. So let's say that 0, 0 is the center of this graph. The distance between the circle and all other points from the origin are always the same. So the radius is unison all around. So the radius for this hypothetically can be 6 squared. And note that each and every term in the circle's equation is always going to be squared. So for example, if I have 36, I would have to take the square root of this to get 6 to find the radius. You find this in lots of standardized testing problems where you get something like square root of 144 is equal to this equation, but you have to remember to square it, which means you undo the square root, getting 144 as your radius. So it's very important to note that the radius is always being squared. So if you're given a number and it's not represented and broken down, such as this, then note that you must take the square root of it to find the radius, or square it to just find the basis of the equation of what it actually equals. Now, another thing to note is that as we talked about how the graph shifts, the center of the graph is always going to be HK. The reason why the center is always going to be HK is because when we move a graph, we're moving it from the center. We're actually moving all of the points, but from a perspective standpoint, understanding that the graph is being shifted from the center is the best way to understand how the center is overall being the main essence of the circle. So let's say we have the points H4 and then K is 3. This tells us that we're going to be shifting 4 units to the right and then 4 units up, meaning that our new circle will be placed right here and everything around it will now become greater. So the center will always be H of K. If H is positive, then we're going to start moving to the right, so we should be switched. And then if H is negative, then we should move to the left. This is because of the zero property rule when we set this as an equation to 0, and that's how we solve. So very basic algebraic concepts. For the radius, we must know that the radius will always be squared, and because of that, we must take into account that's how large the circle will be. So say, for example, this was also equal, after this is plugged into the equation, this is equal to, let's say, 49. We must take the square root of it, so we know that 7 squared is equal to 49, meaning the radius is 7, meaning the distance from the origin to any other point would be 7. That is how the radius works. And then h of k, hk, the point hk, is taking the 2 points from the specific equation, and that will be our center. That is because that's how we're shifting each and every point. Now, this is the equation of a circle. When it comes to ellipses and other different geometric shapes that are very similar to the circle, the process of it is very similar, not the same but similar. When it comes to foci, how big certain parts of things are, but the circle tends to be the easiest because it is essentially the same all around, making the equation very basic but also very simple in terms of understanding. And another additional tip is that the equation of the circle is probably one of the best concepts to learn because of how it correlates with the unit circle, which is probably a concept that we will touch upon later. But up in this top left corner, I'll draw a very small conceptual one. The unit circle essentially states that the radius is always 1 all around. And this is where we get into trigonometric functions, values, and radians. Essentially, any 2 points that you receive or are able to get from the unit circle, you're able to find the radius, and the radius will always be 1. And that's just essentially how the equations of circles can be correlated to different aspects of math, and how they're all intertwined some way, somehow. Thank you so much for tuning in today on Math and Science Problems, the YouTube channel. Please be sure to like, share, and subscribe for more interesting videos such as this. And please comment down below if you have any questions, comments, or concerns about what was taught in today's video. Thank you so much, and have a fantastic day, night, or evening. Take care.